Welcome to The Perspective. Here, we look where others turn away, deep, dark, direct. Today, the theory of relativity, a concept that shook the foundations of our reality, redefined the universe, and shows us that truth often lies beyond the obvious. Albert Einstein, an outsider, a thinker, a rebel, questioned everything humanity thought it knew. Time, space, gravity. Nothing is as it seems. We'll dive into the depths of physics, into the mysteries of the cosmos, into the mind of a genius, and find a truth that sets us free. I'm a Bitcoiner, I see the world differently, and I'll show you what lurks in the shadows. This will be intense, this will be eerie. Stay tuned, it'll grip you. Picture this, it's 1905. Albert Einstein, a 26-year-old clerk at the patent office in Bern, sits in a small, stuffy room. Outside, the world thinks it knows everything. Classical physics, established by Isaac Newton 200 years ago, is untouchable. Time is absolute, ticking the same for everyone. Space is a rigid grid where everything moves. Gravity is a force that pulls objects together. But Einstein sees something others don't. He asks a question that changes everything. What if time and space aren't fixed? What if they bend, stretch, distort, depending on how fast you move or how strong gravity is? From this question, the theory of relativity is born, a work that turns physics upside down, leads humanity into the cosmos, and shows us that truth often lies deeper than we can imagine. The theory of relativity has two parts, the special theory of relativity and the general theory of relativity. Let's start with the special theory of relativity, which Einstein published in 1905, a year later known as his miracle year because he wrote 4 groundbreaking papers in that time. The special theory of relativity is based on 2 principles that sound simple but turn reality as we know it on its head. First, the laws of physics are the same everywhere, no matter how fast you're moving. Whether you're sitting on a train, flying in an airplane, or standing on Earth, physics works the same. Second, the speed of light 299,792 kilometers per second is always constant, no matter if you're standing still or moving at the speed of light yourself. This contradicts our everyday intuition. Imagine this, you throw a ball from a moving car. To someone on the roadside, the ball moves faster because it adds the car's speed. But with light, it doesn't work that way. No matter how fast you move, light always travels at the same speed. This is the core of the special theory of relativity, and the consequences are mind-blowing. One of the craziest effects is time dilation. Time isn't absolute, it's relative. If you move at near the speed of light, time slows down for you. Imagine a thought experiment. You're in a spaceship traveling at 99% of the speed of light. For you, a year passes, you live, laugh, work. But on Earth, 10 years pass. Your friends age, the world changes while you stay young. This isn't science fiction, it's physics. This phenomenon has been experimentally confirmed. In the 1970s, scientists conducted an experiment with atomic clocks. They sent one clock on a plane flying around the Earth while a second clock stayed on the ground. After the flight, the clock on the plane showed a tiny but measurable delay, exactly as the special theory of relativity predicted. Time isn't fixed, it depends on how fast you move. Another consequence is length contraction. Objects moving at high speeds appear shorter in the direction of motion. A spaceship traveling at 99% of the speed of light would look compressed to an observer on Earth. And then there's the famous equation E equals mc squared. Energy and mass are equivalent. This means mass can be converted into energy, and vice versa. A tiny piece of mass contains an enormous amount of energy. This insight led to the development of nuclear fission. In a nuclear power plant, a small portion of a uranium atom's mass is converted into energy, enough to power entire cities. But it also led to the atomic bomb in 1945. The bomb dropped on Hiroshima destroyed a city because the energy from a tiny piece of mass was released. E equals mc squared showed us everything in the universe is interconnected: energy, mass, time, space. Nothing is isolated, nothing is absolute. But Einstein didn't stop there. The special theory of relativity only applied to objects moving at constant speeds. It didn't account for acceleration or gravity. So he kept working for 10 years, and in 1915, he published The General Theory of Relativity, a masterpiece that redefined gravity. Imagine space and time not as separate entities, but as a single fabric, space-time. This space-time is like a stretched sheet. If you place a heavy ball, like the sun, on this sheet, it creates a dip. Smaller objects, like planets, roll around the ball in this dip. That's gravity. Mass and energy warp space-time, and this warping determines how objects move. Einstein's theory explained why planets follow elliptical orbits, why the orbit of Mercury shows a tiny deviation that Newton's laws couldn't explain. It also explained why light from stars passing near the sun is bent, an effect confirmed in 1919 during a solar eclipse. British astronomer Arthur Eddington observed how the light of distant stars was bent near the sun, exactly as Einstein had predicted. Overnight, Einstein became world famous, an outsider who changed the world. The general theory of relativity goes even further. It predicts the existence of black holes, regions in space where gravity is so strong that not even light can escape. In 1916, German physicist Karl Schwarzschild described the first theoretical solution for a black hole based on Einstein's equations. Decades later, in 2019, the Event Horizon Telescope captured the first image of a black hole, proof that Einstein's predictions were true. The theory also explains the expansion of the universe. In 1929, Edwin Hubble discovered that galaxies are moving away from each other, and Einstein's equations provided the foundation for this. Without the theory of relativity, we wouldn't understand how the universe began, how it evolves, or how it might one day end. The theory of relativity isn't just abstract science, it's part of our lives. Without it, modern technology wouldn't work. GPS, the system in your phone, is a perfect example. Satellites in orbit move at 14,000 kilometers per hour and are 20,000 kilometers from Earth. The special theory of relativity says their clocks tick slower because they move so fast. The general theory of relativity says their clocks tick faster because they're farther from Earth's gravity. These effects, time dilation due to speed and time distortion due to gravity, don't cancel each other out, they must be precisely calculated. Without these corrections, your GPS system would lead you astray by kilometers. Einstein's insights are in every navigation system, every airplane, every smartphone. They're part of our reality. But let's dig deeper, beyond the physics, into the meaning of this theory. The theory of relativity is a lesson about truth, about freedom, about individualism. Einstein was an outsider, a thinker who questioned the collective assumptions of his time. In 1905, he wasn't a professor, not a renowned scientist, he was a clerk who thought in his spare time. Yet he had the courage to shatter the dogmas of classical physics. He showed us truth often lies beyond the obvious, beyond what the masses believe. Time and space, which we thought were fixed, are relative, but the truth Einstein found is absolute. Just as Bitcoin today exposes the collective lies of the financial system, that money can be printed, that states can control us, Einstein exposed the lies of classical physics. Both Einstein and Bitcoin are acts of freedom. They give us the power to see the world anew, to break the chains of old systems. Bitcoin and the theory of relativity have more in common than you might think. Bitcoin, through proof of work and the blockchain, is an immutable truth, a system that can't lie, that can't be manipulated. The theory of relativity is the immutable truth of the universe. It describes the laws that govern the cosmos independent of human opinion. Both are products of individualism. Satoshi Nakamoto, the creator of Bitcoin, was an unknown, a rebel who challenged the financial system, just as Einstein challenged physics. Both teach us, truth belongs to those who seek it, who dare to step out of the comfort zone, who question dogmas. In a world that forces us into collectivism, where states, banks, and institutions want to control us, the theory of relativity and Bitcoin are beacons of freedom. They show us, we can understand the world, we can change it, we can be free. What does this mean for us? The theory of relativity shows us, we live in a universe that's bigger than we can grasp. Time, space, gravity, everything is interconnected, everything is in motion. It reminds us that truth is often elusive, that we must question the world, that we must have the courage to seek new perspectives. Einstein was a lone wolf who shattered the collective dogmas of his time, and we can do the same. In a world that forces us into collectivism, the search for truth is an act of individualism, an act of freedom. Just as Bitcoin gives us the freedom to control our money, the theory of relativity gives us the freedom to understand the universe and find our place within it. We're not just dust in the cosmos. We're thinkers, seekers, rebels who can find the truth. Picture this, you're sitting in the dark, the screen flickers. The stars above you are silent, time flows, reality bends, but the truth calls. The air is cold, the chains of the old world rattle, but on the horizon, a light breaks through. This is the perspective. What do you think? Has the theory of relativity changed your view of the world? Do you see the parallels to freedom that I see? Write it in the comments, your voice keeps the mystery alive. If this perspective grips you, subscribe to The Perspective. Give this video a like, share it with the brave. Let's hunt the shadows and find the truth. Until next time, stay awake. The truth is in the code.